Hello, I'm Stephen Perkins. I'm the User Services Coordinator at the Ackerson Law Library, Rutgers School of Law at Newark. And my co-presenter is John Doyle, Associate Director at Washington Lee Law Library. We're going to talk about a few things here. Dublin Core metadata, the harvest, what do you want to call harvest? The harvest browser, broker, retrieval engine, whatever, and resource discovery in law. Actually, the title is fairly ambitious, and we're really not going to be able to do all of that in what we're going to talk about today. I hope to do an article that will do a better job and give sort of a proposal of a way for people to structure documents that will allow us to have better control and retrieval of those documents. One of the things is to say, why are we talking about this? Well, we have a perception that when we're doing research in the World Wide Web and we're using one of the search engines, our thought is that we're looking at a large number of the pages on the web. And in reality, we're not. Various studies have shown that the search engines, at most, each individual engine covers approximately 45% of the pages on the web. So in order to do a search that's comprehensive right off the bat, you've got to use more than one search engine. And because those engines also cover the same pages to a great extent, your amount of increase in the full universe of pages out there is not as high as you'd like it to be. When we do a search, if we do a search, we're trying to find everything where an author's name is John Smith. If we did a search in most search engines, we'd go in and put John Smith in quotes, go for the search. Well, it's going to find every occurrence of the name John Smith in the documents within that search universe. But it's not going to necessarily find John Smith as the author. Hopefully it will do that, but you're going to have to go through your result and try to pull out those instances where John Smith is actually the author of the article. Using some kind of a metadata system and using a search engine that limited itself to searching metadata, and if someone put in as a metadata author name equals John Smith, you'd have a greater chance of finding the document that you're actually looking for. Okay, so one of the ways of doing this is to add metadata inside of the document. And you can do that at the top of the document within the head field of the document in HTML. Now, you can also create metadata that is separate from the document itself. And when we do that, we're creating something else, which we can call a catalog of metadata or a metadata depository. And really, if people are asking, well, what is metadata exactly? Metadata is a description of some object. And that description can be used to find the object. The example for most of us familiar with is a card catalog, online catalog. It is really a collection of metadata. It's a metadata depository that we search to find the physical item. Okay? So using that depository, we have a greater chance of finding the object if it's in the collection. Why? Using metadata, easier to search the metadata than the whole document, can be held in the metadata depository, will allow a focused search on elements. We could search for John Smith as creator for using DC or Dublin Core metadata. It would be called creator and not author. We could search for it as a collaborator. That is another possibility of the descriptive term we used. There are all kinds of ways that we could find an individual, or we could find some information about the item. It can be attached to images, to databases, PDF documents, to books, articles, whatever. So the use of the metadata can be used to describe all types of media and objects within those media. Now, there are various metadata schemes. The one we're really talking about today is the Dublin Core metadata. And Dublin Core was developed by OCLC, by a gentleman named Stuart, and I'm going to say Bible, but I don't know how he pronounces his last name. It's W-E-I-B-E-L. And he is working at OCLC, the Online Computer Library Center, which all of us, I believe, are familiar with. The Dublin Core started out as 13 identifiers that he wanted to use, and the idea was that Dublin Core could be applied by the author of a document, so that it didn't require an expert to apply Dublin Core. Okay, but it could also be used by an expert to describe something. So a cataloger could actually use this in a way and catalog the internet, the electronic documents on the internet. There have been several extensions to Dublin Core. There was a Warwick framework which was developed in Warwick, England. And Dublin in this case is not referring to Ireland but to Dublin, Ohio. The Canberra qualifiers, and I'm told I pronounced that incorrectly. Mr. Doyle here will give us the proper Australian pronunciation later. This was another meeting in Canberra, Australia, where there were extensions made to the way the core was worked with. At the same time, there are 3 versions of the Dublin Core. Dublin Core 1, Dublin Core 1.1, which should be finalized this year, and Dublin Core 2, which is Dublin Core, what's called Qualified Dublin Core. The use of Qualified Dublin Core has come about because people found that the 15 original elements were not enough for them to describe certain types of relationships within documents, or they were not enough for them to describe the document so that it would fit into a local scheme that was being used by a library or something else. There's a great deal of discussion going on in regard to Qualified Dublin Core. And Qualified Dublin Core sort of moves us away from the original intent of Dublin Core, which was something that could be applied by an author without a great deal of thought. You didn't have to be a cataloger to understand it to do this. Now, Dublin Core is somewhat based on MARC, U.S. MARC record, which we all should be familiar with here. And the MARC record system, Dublin Core can be translated into MARC so that it can go as a method for you to create MARC records from these types of documents. It can also be used with Z39.50, so there's a number of ways that it can be used. There are other schema. One is the Text Encoding Initiative, and that's been developed by mainly humanities scholars. It has 2 different types, the Text Encoding Initiative, the full set of descriptors, which is extremely complicated, and Text Encoding Initiative Lite, which I also consider to be complicated. But those have been developed to allow humanities scholars, people who are interested in analyzing literary texts, to do that and to mark up a literary text in such a way that an individual could go through it and look at all of the changes, all of the drafts, or whatever happened with that text by the use of the TEI markup. Another metadata format is the Platform for Internet Content Selection, which was developed by the W3, the World Wide Web Consortium at MIT. This was originally developed to allow you to say that a page has adult content, does not have adult content, it's for children, it's for young adults, or whatever, and to allow this to automatically be checked by a browser or some other kind of agent to find pages that you wanted to allow your children to look at or not look at. This is also capable of being extended to do digital signing, and I think that's going to be an area where it's going to become more important in the future. So this is a way to authenticate a document as well through the use of the PIX metadata format. Now, why would we want to use Dublin Core? Well, again, it has been developed with reference to the machine-readable cataloging format and international use in libraries. It's been developed to allow for use by creators of documents as well as resource description experts, right? Anyone who makes a web page can go in and put meta name equals dc.creator content equals your name. Not exactly hard. You put that up in the head /head element of the HTML page. There are, of the 15 elements, most of them are fairly descriptive. Some are a little arcane, and you get a chance to take a look at them and you'll see what they are. The identifier element is actually what is the URL or the URN for the resource you're looking at. A few other things like that don't exactly fall where you think they should. The other thing is that creator is used for author. There is no dc.author tag, it's dc.creator. It's the subject of an ongoing development effort led by Stuart Bible, and you can find an RFC on this, an informational RFC 2413. It's linked here. If you go to this page, you can go to that and get it. It's a short document, actually. It describes the elements of the Dublin Core and how it would be used in resource discovery. Some examples of Dublin Core metadata depositories. The major one, in my mind, is the Nordic Metadata projects. What has happened here is that the Nordic countries have gotten together and they have tried to create a metadata depository of their library materials. So that you can go to this one place and search all the libraries of the Nordic countries, the national libraries, the large university libraries, all of that, through this depository, and they have marked up their data using Dublin Core. They have made some modifications to meet their needs, and in that sense, there's some slight difference here, but this is set up to be Dublin Core version 1 compatible forever. Okay? So any kind of a search engine which you might have that can search Dublin Core version 1 metadata will be able to use this depository no matter how long they have it up. Now they are talking about going to, or the last thing I saw was they were going to Dublin Core version 1.1, and they're looking at Dublin Core version 2 because 2 is not yet finished, and we really don't know what the qualifiers are going to be. But if you go to this page, you'll be able to get to all of the various parts of the projects that they have. The Government Information Locator Service, put up by the United States government, uses some modified Dublin Core. It's also built on some other metadata formats. This is another one for you to look at so you can get an idea. But it's used for Global Information Locator Service and the Government Information Locator Service. If we go down, I think you'll get how to find information, infrastructure for Global Information Society, all kinds of things. But this is another example for you to look at. OCLC itself has a page off of the Dublin Core page where you'll find other Dublin Core metadata projects. And they can be arranged by geographical region, by sector, and by subject area. If we look by subject area, you can see there are a number of different ones. Many of these have been created in Europe and Australia. There are very few that are actually housed in the United States. The U.S. hasn't really seemed to pay too much attention to the metadata and how we can use it, whereas Europeans have made a lot of effort in this area. There is a European Web Index which uses metadata and attempts to index all what they consider serious web pages in Europe. And all kinds of other subject areas that have had metadata depositories built for them. Now, you can create Dublin Core by hand. And there's a user guide reference down here that will show you how to do that. You can also create Dublin Core by using some tools that have been put up on the internet for your own use. And one of these is called DC Dot, and another is Reggie. Reggie is a Java application, and it has to be loaded onto your machine. DC Dot is an application that resides in the UK, but you can drag the icon for DC Dot onto your toolbar and put it on your browser so it's always available to you. But if we look at this, to use DC Dot, we simply type in a URL of some page that we want to look at. We'll look at this page. And if everything works. Okay. This is the result of running DC Dot against the web page that I'm using for this presentation. In that page, I've added metadata for title and creator, and that's it. The program itself has gone through and added the link rel at the top, which is to say what's the scheme of the metadata being used. It's the Dublin Core, and it comes back to an href where the location that you could find that schema. If it was a different schema, it would give you the reference back to that schema's location where you could look at it. So there's other schemas that could be used. Title, I put that in. Creator, I put in. Subject, it pulls the subject out of our heading on the page. This may or may not be good enough for you. You might want to edit this. You can actually save this document, edit it, and put it back into the page itself and replace the metadata you had with this if you wanted, or you can save this into a separate file and start building a depository of metadata. Okay? Down here it says publisher, and it's pulled out Rutgers University. Date, it's using a scheme for the date, again to show you how I can find those, and puts it in 1999-06-19, and looks at type and says this is text. Format of the text is HTML, content 6599 bytes. I actually see that on other pages, so I'm not quite sure if that is a valid move. Then DC identifier is the web page address. Okay? So all of those was created, most of that was created for you by the DC dot generator. Now, we've got that at the top. We can scroll down and you can edit all of your sections of the Dublin Core elements. We can go here on resource type where we said it's text. Well, it could be text, image, sound, software, data, interactive. This is a simple way of doing it. We can go over here to the complex, and you can see we've got all kinds of different ways we could describe the page, depending on what it actually is. Rights management, we can put statements in here about copyright, things like that. You could link to a separate copyright statement if you've got one for all pages for your law school, something like that. So you could add that in. Again, and then you could save this page. You can email it to yourself. You can use it to replace the data you already have in your meta tags on your page. You can save it and start a depository. Reggie is the Java application. I click on that, but we tried that up in the lab, and it took a while to load.
And so it's really something you should try with your own computer. This is a user guide working draft. It's not a very long document. There have been, as you can see, 4 different versions before this. Here's the author of it, and you could contact that person to discuss anything in this that you don't understand. But I would suggest that if you want to use Dublin Core, you want to find out more about it and how you would use it, you read this document. It'll give you a better idea. Again, this is for version 1 of the Dublin Core. They're working on a new user document for version 2, but since we don't really expect version 2 to be finished for a while, it'll be a while before you see that document. Now, what's the future of metadata? Well, I'm going to say the future of metadata is resource description framework. The expert for us is sitting up here, and Nick Finke could tell us what he thinks the future of metadata is. Resource description framework, it's an XML application that describes metadata, allows for multiple associations between metadata. It can do a lot more than just, be a descriptive format for us or a way to find things. It's really going to change the way that we look at the web when this happens. There is an article here, application of RDF for extensible Dublin Core metadata. This is by the Resource Discovery Unit in Australia. You might want to read this one. It says not for distribution outside W3 RDF. However, it's been put out on the internet, so here it is. You might want to look at that and get some ideas to what you would do. There is a mailing list called DC General that you might want to join. I haven't put that information on the page yet, but I will put that up. There, a lot of the working drafts get published to that list, and we go through and read them and make comments about them. 2 have been published within the last 2 weeks, actually. There are a number of working groups within the DC Core group that work for each of the elements. The 15 elements has a working group. And those working groups are working on working papers or drafts to tell you how to interpret that element of the Dublin Core. Also, if you recall, when we were looking at DC Doc, it could take your metadata or your page and it can output that in RDF format. How valid that RDF format is at this point, I'm not sure. And I wouldn't try to say, it's good or bad. I think somebody else who's got more familiarity with RDF and XML than me would have to make that decision. There's a paper here that explains RDF in what I consider a readable manner. And here is another RDF tool page which has information about some RDF for Dublin Core, an example representing Dublin Core metadata in RDF. See, it starts as XML, namespace. Again, the Dublin Core location where you would find its schema, description, title, creator, identifier, description. There are some problems that are coming up in the use of capitalization in Dublin Core. XML in general does not use capitalization. And there are some questions about how RDF representation of Dublin Core metadata needs to be formatted. So we're having some problems figuring out how to do that, because the Dublin Core specification is for capital D, capital C, period, and a capital letter for the element name. Some people say, well, what difference does that make? Because once you pull it into some of the parsers, it all gets changed to lowercase anyway. So we're not quite sure.
All right, search engines that support metadata. There's a list here at Search Engine Watch. Basically, all but 3 of the search engines that are watched there do it. However, there are some differences in the way that they use metadata, and in reality, they're not looking at DC metadata the way we would like them to. They're just looking at it as within the meta tag. Using Harvest to retrieve and index metadata. We started out trying to use Harvest to index metadata, to retrieve it, to index it. Harvest uses a metadata format called SOIF, and I forget exactly what that stands for. But that metadata format comes out of IAFA, which is an international association which has set up some of the standards for metadata. SOIF and Harvest, as it's set up, will find metadata, but it doesn't find just DC metadata. So if I'm looking for pages that only contain DC.creator statements, Harvest probably can't find them for me. It may find them in a sense it finds that there is metadata there, but it's not finding just the instance of DC.creator. So we're looking at some other stuff there. There is a web browser called HotMeta, again developed in Australia, which is attempting to be set up to work directly with the various metadata schemas and to have a format that will work with Dublin Core to retrieve only Dublin Core aspects of it. John will now talk about setting up Harvest and some of the things that he's done with it.
Thanks, Steve. I have almost nothing to say about metadata, actually, which some may find refreshing. Basically, Harvest is a generic tool for retrieving documents from the internet, indexing them, and dishing them up via a web server to clients, web clients. That's its function. It is very good at dealing with data that's organized into attributes and values, into names and contents. So it deals with matching pairs of things very well. If you have data which is organized in some way into name and in some descriptive portion of that name, as in DC.creator, John Smith, something like that, it can deal with it, and it will allow you to search that kind of data once you've retrieved it. So, Harvest is a set of tools which operates on Unix. You have to have a Unix box to operate Harvest. You also need, on that same box, if you're running the whole package, you'll need a Perl interpreter, Perl language, and you need a web server. So if you've got all those, and most people here from universities would, somewhere on their campus, have all these things, they could download Harvest and install it on a Unix machine. I'm going to give you an example of the only database which I've done with Harvest so far, and I'm hoping it works. This is the front end that I created. This is the query.html page for this particular broker, as Harvest calls their front-end interface. It comes to be called the LawDB database, which is an arbitrary name I gave it, and this is the query page. So we could enter a search here. It relies on Glimpse, which is another Unix program which underlies Harvest. Glimpse is an independent indexer. Harvest itself has no indexing capacity whatsoever. It relies on an external indexer of some kind. And it can utilize various indexers, but the standard one that comes with the source code is Glimpse. So there are some possible toggles here for things which Glimpse understands. That is, do you want this search word or words here to be substring entries? You know, you type in AUST or something. Whoops. All right. AUST. And if you're searching for a substring, of course, it will find Australia, Australian, and so forth. Or if we say no, it may or may not find anything. Well, let's okay. What this is a database of all the source descriptions or IDEN type information for Westlaw and Lexis. So I think both Westlaw and Lexis merged together. These are all the source descriptions for both systems. So it has about 32,000 records in it. Mostly databases, but some of them cross-references for databases. So you can see these are library files. So these are Lexis ones. These here are Lexis. And you can click on something and it should take you to Lexis. You sign in and so forth. And you're in a searchable file. How do we get a back button? There it is. And let's see. And so I have over here some descriptions of various fielding information that you could put in. DB name equals AUST, for example. Right, equals AUST. And it will find anything that I happen to put into a field for a database name, which is going to be presumable Lexis files because that's a library in Lexis. Or we could have said, and say title equals Australia, something like that. So I have some field information in the records here. So now this is what we call the title here. This is this element here. So all of these records you should have Australia somewhere. Okay, well that's just a practical database that I created with Harvest, just to show you what it can do. You can pull up matched lines if you wanted to. You can set the number of entries that you want to get back from the system. The source code comes from University of Edinburgh. It was developed originally University of Colorado, but it's now gone to England. And you can download the Harvest indexer here, and there's a bunch of documentation, some of which is kind of old. It's back from the Colorado days. Okay, not too interested in the way it was configured. I just put this up for general interest in case anybody wants to go to it later, which is at www.edu/harvest with an uppercase H/docs, and want some help in configuring Harvest, which I have to say is fairly complicated. It took me a couple of weeks to get a reasonable familiarity with it. I'm still working on quite a few subjects in it. So you can compile it with prefixes to where you want the system to be loaded, the program to be loaded, which I chose as apps harvest. So a bunch of things down here are going to say apps harvest. That's just where the home directory is on the system, on the Unix system. You'll need to change your web server a little bit, add in some script alias and so forth. But your web server administrator can do that for you if you're not yourself the administrator. Harvest has two components, basically. It has a gatherer and a broker. The gatherer is by far the more complex part of the whole structure because it has to go out to the internet, grab documents, pull them back in according to some configuration, which can be quite complicated because you have to make sure not to retrieve the entire internet, which you could do with Harvest if you're not careful. Well, I exaggerate. You're probably not going to be that careless, but potentially you could use this as a robot and you could retrieve everything that's on the internet with Harvest. Having retrieved documents, the gatherer is going to summarize them according to whatever the type of the document is. It's going to look through some heuristics and determine what type of document the incoming document is, based typically on the extension .html. Maybe something in the URL, maybe it starts with news, so it knows it's a Usenet news group. Maybe it's got a question mark in it, and it knows it's an HTTP query. Maybe it has CGI bin in it, knows it's an HTTP query of some kind. If those fail, then it will actually pull the document in and look maybe at the first line to see if there's any Unix information in it which tells it what kind of file it is, or maybe it'll actually look at the content. So one way or another, it has to discover what type of file is being pulled in. JPEG, GIF, PDF, whatever. Mostly what we're interested in, of course, are HTTP files, but it's perfectly capable of pulling in everything off the internet for you. The gatherer then sends the file through a summarizer. separate program which he calls Essence. And Harvest is built on the assumption that the files are going to be summarized, that you're not going to retrieve and save the full text of every document that comes in. It doesn't stop you from doing that. You could do it. We'd have to change the default configuration, but it's easy enough. But the basic assumption is it's some kind of a digesting operation. You pull in a PDF, you're just extracting the text. You pull in an HTTP document, you're selecting some of the tags from the file. You're saving those into the format which Harvest uses, which I'll show you in a few minutes. The gatherer, then having saved each of those documents into a separate file, and they can be fairly small or they can be quite large individual files, is going to fire up a gatherer daemon. In other words, a piece of software residing on the Unix system which is going to listen to a known port and wait for another part of Harvest, possibly on another machine somewhere else in the world, to ask it for records that have been added to that gatherer since the last time the broker asked it for the information. So there's two very distinct pieces of software in Harvest that can be run independently. The gathering portion of Harvest could be run on many different machines. You know, someone in Australia could be gathering everything about legal information in Australia on one machine. Someone, so it could be analysing all the bankruptcy documents in the world, whatever. So there could be a whole bunch of gatherers out there collecting all this data. At some point, some central broker is going to, in a configuration file, know which of these gatherers exist at what port and what machines, and it's going to query them all and say, what have you got since I last queried you? And each of those gatherers will send the files to the broker. The broker will index them using Glimpse and will make them available via query through a web query page. So that's kind of how the whole structure works. Don't worry too much about that. This is more related to the internal structure of the Unix system and where all the files go. There are massive configuration files in Harvest. Unfortunately, they're not well coordinated, and there are lots of different directories. And it helps a lot if you know Perl programming, because many of the configurable files in here are written in Perl, and if you want to tinker with them, it's best if you have a rudimentary knowledge anyway, and better even if you have a really good knowledge of Perl. I would say if you want to do much that's different about this and not accept the standard configuration, you're going to need quite a lot of Perl programming, really. There's some scripting language anyway. Okay, you fire up the whole thing by running a program called Run Harvest. Initially, Run Harvest will create a broker and a gatherer on your machine according to whatever port number you specify, 8501, 8502, something like this. That sets up the directory structure, which in my case was apps harvest gatherers, LawDB, apps harvest brokers, LawDB, and then various configuration files were established in those directories. Okay, we're in the gatherer part of the system at the moment. I want to show you the configuration file which is used by the gatherer that's dealing with that Westlaw Lexis database, and there's actually nothing to it because of the way I designed it, so it's not very educational, but there's only one line in it which says every time you run, and this program would be run by the cron process on the Unix system. In other words, whatever you establish as the frequency that it should go out and get the documents in that particular directory or set of directories. So there's more than one you have to establish through the Unix cron process how often you do this. And it depends how often that data changes, of course. If it doesn't change very often, maybe once a week, once a month, or whatever. Maybe you should do it nightly. It depends. All this is saying is go down to a dep1, which means just grab this directory, this particular one here at doyle.j/ODB, and pull in every single file that's in that directory. And that's actually where the Westlaw Lexis materials reside. I actually use a separate process to download them. I'm not going to be doing that in this talk. But there's a difference between root nodes and leaf nodes. I haven't got any leaf nodes here. The root nodes say, I want you to recursively descend down through the hierarchy. And this is where On the right-hand side, after the URL, you can establish a whole bunch of parameters describing what the limits are on retrieving materials when it recursively descends down through the hierarchy on the remote machine. If you just have a simple one URL and you don't want it to descend down through anything, you just want to retrieve the document, then you can stick it in this particular area down here. Okay. The format for establishing the limiting parameters on what you want the gatherer to collect is shown here. And just here's an example, which is not really real life, but these escape slashes at the end here just indicate this is really all one line, except if you want it to be on separate lines, you have to escape it like this. So this is just a requirement of the gatherer. If you really want it all in one line, it doesn't have to be, but if you're going to put it on separate lines, you have to say it continues on the next one. These over here aren't part of this, these are the defaults for configuration. If you don't specify anything, you just simply say http://law. These are the defaults that are going to occur. What will happen is it will pull in no more than 250 URLs. When it starts descending down through the hierarchy of HTTP files, looking through all the anchors, following all the hrefs, that's as many as it will pull in max, if you don't say anything different, as in the left. It will only pull in materials from one host, in other words, the one you start with, which is an obviously sensible thing to do, because if you think about those anchors in HTTP documents, they can go anywhere in the world. And you don't want to start descending down through remote machines that you don't know anything about, don't care anything about. You may want to, but you probably don't. It defaults to only retrieving HTTP links. It won't retrieve FTPs, Usenet News, this sort of thing. Has a delay of 1 second by default in terms of being polite to remote systems. The only non-conservative default is the depth. The depth of 0 is infinity as far as the system is concerned. So here's some other examples over here that I'm just saying, for an example, you could say I want a maximum of 1,000 documents, I want 2 hosts. Let's say there are 2 hosts on your particular university that has relevant information. I want more than HTTP. I'm willing to take FTP and go for, well, there's 60 seconds probably silly, but and maybe willing to go down in one site down 10 levels, just as a security feature so it doesn't run away in some way. There are 2 extra things here. There's a filter file related to the URL and a filter file related to the host. Those are just separate files in the directory that Harvest is going to look at to determine if the URL that you're asking it to retrieve matches in some sense with a filter file that you put up, which has a listing of Unix regular expressions, whereby you say, let's say in the host thing, it has to have wou.edu at the end of the host name. If it doesn't have that, I don't want to do it. Or on the URL filter file, maybe it has to have /law in the path somewhere. If it doesn't have that, I don't want to do it. So these are protective measures to try and retrieve certain kinds of information. If you want to know what SOIF means, which is the format that material is saved in, it's a summary object interchange format. Interchange, I guess, because they're thinking it's an easy format to interchange between machines, and it is a summary format creating an object of some kind. Okay, the gatherer retrieves the information. What does it do with it next? First thing it has to do, as I said, is it has to determine, hopefully by the name of the object, what kind of a type it is, so it can know how to summarize it. Each different type, HTTP, news file, PDF, whatever, is going to have a different summary file. Mostly they have these by default on the system in the Harvest configuration, though you can create your own summary files, and that's a very nice feature. If there's some special kind of text that's being pulled in, it's specially formatted, you can create your own summarizer, expand out the materials into those SOIF formats. So the byname.cf configuration just has a lot of these Unix regular expressions in it, which says if it ends in this, it's this kind of file. Okay? And there's just one in there that I added. I really don't have time to go into it very much, but it will explode out a file that ends in .NET. It's what I use for the Western Lexis materials. So the incoming file looked at. Harvest now knows what kind of file it is. It will check a stock list to see if you really don't want to deal with that type of file, a C++, a Fortran file, whatever, assuming it passes that, it goes to what's the most important part of the gatherer, and that's this file. It's a table used by the HTTP summarizer. And this is where, in fact, there is some information about meta stuff in here. What these are the tags in the incoming HTTP files that are going to go into that attribute value portion of the SOIF format. What it's going to see is, okay, I've read in this file, it has a title, and within that title area, where I'm going to put it is in the title field, and I'm also going to do this funny little thing here called parent. Parent just means also put it into the next highest tag, the one above title. So title is in the head portion of the document, also stick it in head. And assuming there is a head defined here, which there is, that's where the title will go as well. So title both goes in this configuration, which of course is extremely changeable. It will go both in title and in head. If head didn't exist, it would go in HTML. If it exists, if it does, fine. If it doesn't, it will just junk it. It wouldn't retrieve it. It wouldn't store it at all. So that's why if you have a very limited number of these tags, you end up with a very limited saved set. I'm going to have to hurry through this because we're running out of time. But that is the most important table probably for the saving process. These are just some quick examples of how you might have a very limited table like that. What this says is, if the tag is a meta tag, then put the content of the meta tag, the John Smith part, into whatever the name is called. In other words, dc.creator, let's say. So in other words, there would be created in the saved record a field called dc.creator, and it would have John Smith in it. If it sees a title, it's going to go into a title field, and these are completely arbitrary names. Whatever you want to call them is whatever gets put into the saved record. And we're creating something we're calling keywords, just as an example. Everything else is completely ignored. There isn't anything else that's going to go back up to a higher level in the tags and be saved. Probably didn't really need to say ignore there, but that's what that means. So ignore, parent, these are specialized meanings. These are not really field descriptions. And this is what sort of the lines look like in an SOIF format. The field name, the number of bytes to be found in that field, and what's in the field. It's pretty simple. Another possibility related to something we saw a bit earlier about the .NET, the Exploder process, is you could have, and I use this for the Westlaw Lexis database, is you could have on a remote site somewhere a file which has a bunch of records within the one file. So instead of pulling down one file after another, you could, if you had a, let's say, a meta tag depository of some kind, you have a bunch of records within one file. And if it has something identifying about it, as in, for example, ends in .NET, which was just something I invented arbitrarily, and you have some kind of script which knows about the format of the incoming file, then you can have Harvest call that script, push the incoming document through the script, and it will explode the whole thing out into a bunch of SOIF records, and it will go into the database. That particular script looks like this. It's the Perl script. This is the particular format that I chose arbitrarily to create for that Westlaw Lexis database in its raw sense before it even comes into Harvest, and this is just the Perl stuff to deal with it. It's not terribly complicated, but it helps if you know Perl, obviously. So here's a real live SOIF record. This is what they look like. They're not particularly attractive. They start with that file. They have the source of where this document supposedly resides. They have some things in here which relate to Harvest, as in when Harvest will eliminate the file, in how many seconds this file has to live, basically. At some point, the database is going to die if you don't refresh it. All the objects in the database that the broker has pulled in from the gatherer don't live forever in the broker. At some point, they're assumed to be stale and they're eliminated if they don't get replaced or updated. So you can see how they have this. They have the name and they have the the attribute and they have the content of some kind in each of these files, and they're all searchable, as in that front end, that query.html, where you could have said something like description equals Syria, for example. That would be in the database. You could have said that. I didn't have anything in that query.html to tell you you could do that. It's sort of up to you at the front end to design some kind of a query page. And again, none of this has a whole lot to do with meta tags in a sense, except that this system can utilize them because it likes this kind of parallelism between names and contents. You can use Harvest to index your own, web server. For that matter, it's quite a generic tool. Okay, the broker is the other aspect, and it has some somewhat simpler materials for configuring it. It's not as complex. There's actually only one line in it that's of any relevance. Maybe you can't even see that. It just says liberty.uc is where the server resides. My server resides on port 8504. 3 just means do an incremental update. In other words, keep asking the gatherer whether it's added anything since the last time that is the broker, asked you about it. So you have to keep in mind always that Harvest has two completely separate entities. The gatherer, possibly lots of different gatherers on different machines, and the broker that asks for that data, indexes it, and dishes it up. And the other piece here is the broker.configuration, which deals with, which is a rather, which just sets up basic things about what kind of indexer it's using glimpse, what port is it running on, and so forth. Don't really need to go into all this. I think I'll stop here. Some of you may want to get the 5 o'clock bus, or some of you might want to ask some questions, so I'll just leave it at that. If you want to read this page, go ahead, you can read it at home. Anybody have any questions for either of us?
The reason we chose Harvest was that Harvest is free, and the idea was to see if we could adapt Harvest so that it would search for the metadata and the DC creator, and then we could come up with a solution that we could say, well, try this and see how it works for you.
Well, whether you buy into the metadata or not,
right.
You can still use Harvest, and it's a great tool. A little arcane, though.
What's your opinion about using Harvest versus using some other form of enumerator that would keep your metadata in relation to?
Well, yeah, Harvest is kind of a cheap and it's sort of a poor man's database, really. Glimpse isn't that great, I don't think. You'd be better off perhaps using Harvest to pull things in, and SQL, a commercial database, I would think of some kind as a back end to it.
The hot meta people are using MySQL as a database backend.
But you can't beat the price. It's free, so it doesn't do a bad job. And Glimpse is fairly fast. You get a response back in a few seconds, so it isn't bad.
What kind of scale are you guys thinking of?
We don't know. Right now, we want to do a proof of concept, and I'm thinking of looking at the jurist base where it has law professor web pages and running that and seeing what we can come up with that. We're really, just sort of trying to figure out how we do it for law. As you can see, when I showed other projects that are running, a lot of other areas. There's a physics new papers database that uses metadata for that. There are several others in arts and humanities, museums, a lot of things, but there's just very little in law. I was contacted a few weeks ago by someone from Australia about a project that's just starting now in Australia to do this with metadata depository for Australian legal materials. So as far as I know, that's pretty much it.
The pronunciation for the capital of Australia is Canberra.